Today we are moving to target 13B. All right, and by this time you should have noticed that target 13A was pretty easy, just reading how to read the graphs. Okay, well 13B has a little bit of reading a graph and a little bit of how we're solving quadratic equations. All right, so let's read at the target. Our objective for today is to determine appropriate domain of a quadratic function that represents a context. And again, domain, we introduced domain in KC 11, okay? And domain means the x values, the x-axis. Okay, just in case you guys forget, a little reminder what domain means. All right, so let's try number 1. It says determine the intervals where the roller coaster is decreasing for each function. So it's decreasing. All right, from our first graph, we notice that it's decreasing from this little side here, and it's increasing another side over here. All right, so to write the intervals, okay, you're going to start from the x-axis because, again, we're looking at the x. So it starts at 0. So it's going to be 0, okay, and it's going to go to 200. And we also have another one that starts at 300, okay, and it goes to 500. So this one had 2 answers. All right, let's try the next one. Again, the intervals where it's decreasing, well, we only have one, which is this. And again, we're focusing on the domain, so the x. So this is my x. So it starts at 0, and it goes up to 2, where it stops. So those are my intervals when it's decreasing, and that's how we're writing our answers. All right, pretty easy. All right, number 2 says determine the interval where the seller earns a profit. So P is the number of people and C is the profit. All right, well, again, we're focusing on domains, right? All right, so we're focusing on the X. And where the seller earns a profit, well, it earns a profit at all times throughout the whole thing. So it's actually the whole curve. So it's going to start from 2. From 2. And it goes all the way to 48. Pretty easy. All right, same thing with B. It's just the curve, okay? And we're focusing on the X. Well, the X is crossing through 1 and it's crossing through 3. That means it's from 1 to 3. Pretty easy, okay? And number 3 says in the context of the image below, explain the meaning of the domain. So explain what's happening. All right, what's happening on my x-axis? What's happening on my x? All right, well, these problems look like the problems from Target A. Remember when they threw the bouquet? Okay, when the bride threw the bouquet, or when they threw the basketball or the football. Okay, well, what's happening on the first image? Well, on all the graphs, our x values was always time. I don't know if you guys remember from your Target A, and your y was always the height. Okay, so then that means that the image represents how long it takes the ball to hit the ground after throwing it. All right, so what about B? What do you guys think? This one doesn't hit the ground. This one's still in the air to get to the basket. So this one is actually how long it takes the ball to hit the basket, to go in the basket. Okay, so for these, you have to explain what's going on. And these should be easy because these are the same problems that we got from Target A. And Target A explains it to you. So it's the same thing. All right, number 4 or 5, we have to do some work, but it's okay because we learned this in KC12. All right, and again, we send you guys videos for KC12, so you should have done that, and you guys did a quiz. So it should be a little reminder, okay? So number 4, let's go and read the problem. It says the cheerleader launch a t-shirt to the stands during football game. The pad of the shirt is modeled by the function f of t equals negative 16t squared plus 80t. Algebraically determine the domain of the function. Express the answer in inequality notation below. And again, inequalities has or greater than, less than symbols. All right, so we just have to determine from when does it start and when does it end. All right, well, how do we do that? Well, we get the function they give us and we solve for t. And we know how to do this, okay? Well, we need to take out what they both have in common. They both have 16, so that means I could take out negative 16 out of both of them. So then that means I have t squared plus 5. Oops, I took out that negative, so 80 divided by negative 16. All right, let me show you a little bit what's going on. When I take out the negative 16, I'm dividing both of them by negative 16. Okay, because they both have 16 in common. And how do I know they both have 16 in common? Because when I divide, this is going to be 1, but I don't have to put the 1, so I just put t squared. 80 divided by negative 16 gives me negative 5. And I still have a t, so take that t out. All right, and based on inside the parentheses, they both have t in common, so I could take out a t. So then I have negative 16 t, and then inside I have t minus 5. All right, I can't do anything else with it, so then this is where I get both of them and set them equal to 0. Okay, so now I have negative 16t equals 0, and then I solve for it, and then I have t minus 5 equals 0, and I solve for it. All right, well, over here I need to divide by negative 16, so t equals 0, and over here I need to add by 5 for both sides, so t equals 5. So there you go, I got my two answers. It goes from 0 to 5, and this is my final answer. All right, pretty easy. All right, let's try number 5. How about you guys try this on your own once you are done? So stop the video, do it on your own, try it. Once you come back and check your answers should have been 0 to 2. All right. And number 6, let's go to number 6. It says the graph and table below model the stopping distance of an automobile under the different road conditions. So look at the table. The first table tells you that stopping distance at a dry roadway. So it's dry roadway. And the other one stopping distance on a wet roadway. All right, so one is dry, one is wet. All right, so what is a reasonable range for each road condition? And again, range means y-axis. Okay, so that's why they have this the value of y here. And every time we are writing this, remember we're writing in intervals, so we should have our symbols. We just have to figure out when does it start to when does it stop. All right, from the table, well, obviously, they told you the speed is 20, but obviously we all know that the speed always starts at 0 because every time you're driving, you start from 0. Okay, so they didn't give you all the information from the table, but you should know that when you drive, you start from 0. All right, what you do know is when they stopped was at 55 miles per hour, and that was 103. Okay, and the graph, you could see that they start at 0 and they go all the way to I want to say like 220. All right. And remember, we're focusing on the y, so that's why I'm looking at the numbers on the y, not the x anymore. All right, so it says compare the ranges of the models, explain what they mean about stopping distance under certain conditions. Well, based on the table and on the graph, it takes longer to stop on wet conditions or wet surface. So based on the two intervals that I got, one from the table, one from the graph, I know it takes longer to stop on a wet surface. All right, and that was number 6. How about you guys try number 7? Again, you're trying this on your own, so you could test yourself if you're understanding the notes so far. All right, so your answer should have been 0 to 33 for the table. The graph should have been 0. And don't forget to write your symbols here, okay? The greater than, less than. Greater than or equal to, sorry. So for the graph, it goes from 0 to about 121. Well, let's put 120. All right, so then it says compare. Well, what are they talking about? They were talking about McDonald's, the income at McDonald's, and the income as teachers. McDonald's. So what can you say about this? Well, obviously the table for McDonald's is 33 and the graph goes to 120. So we know that a teacher makes more money than a McDonald's employee. So these were your answers. Again, once you try the problem, stop the video, and then check your answers. Don't cheat on yourselves. All right, number 8, we're almost done with the notes. Number 8 and 9 are pretty easy. Okay, again, we're explaining, talking about the graph, trying to understand the graph. It says the model below represents the Chevrolet sales per year for the interval 0 to 4. Okay, and they're talking about the x. It says determine the years when the function is increasing, or increases from this point to this point over here. All right, the time in years since 2010. So that means at 0 is 2010. If I add 1 year, it's going to be 2011. So that means that this year is 2012. And by this year is going to be 2014. Because this is where it stops, right? At 4. So it goes from 2012 to 2014. Alright, it says determine the years where the function is decreasing. So that means it starts from here to here. This is decreasing, it's going down. So that's from 2010 to 2012. And it says, in which year was the Chevrolet sales the least? Well, obviously, we know it's going to be at 2012. That's their list. That's their minimum. Okay, so 2012. All right, pretty easy, right? What you do have to understand is that you need to add the years based on the years that they start from. You need to read this information. It's very important. All right. So for number 9, it's very important that you understand that the time they start is 1890. So this very beginning point is 1890. What you need to do is add the rest of the year so you can figure out the year number. Okay, so again, number 9 is try it on your own. Stop the video, try it, and then come back and check it. Alright, so once you came back and check your answers, you should know that for 9a, it says determine the years when the function is increasing. Should have been this side right here, and it stops around here. Okay, so this is going to go from 1890 to 1955. And what did I do? I just added a 65 because it's right in the middle of 60 and this point right here, that should have been 70. So that's how I know it's 65. So 1890 plus 65 gives me 1955. That's how I got it. And that's how I told you have to add the years. All right. So it says determine the years when the function is decreasing is this side over here. And you should have put 125. So we already know what year is this. This year is 1955. So 1955 plus 125 will give me the year. So that should have been, oops, 2015. So it starts at 1955 and it goes down all the way to 2015. And it says which year was the average number of the hours the greatest? Again, greatest means max. So what year was that? 1955. And that's it. Okay. That's the notes for today. Hopefully we understand the notes pretty easy. Again, a review of what we learned yesterday and a review of what we had learned in KC12. All right, if you have any questions, please email or send a reminder message to your teachers. And hopefully we are doing our work. Again, if you have questions, just send us a message and we're here to help you guys.